Welcome to the CAD Office Training Guide series for F.Dot Connect. I am Joe Brenner, the lead structural engineer at WSP USA. Today I'll be going through the OpenBridge Modeler Training Volume 1, Introduction to Model-Centric Design. In this series of videos, we will be taking you step by step through each exercise from the guide. In this session, we'll go through Chapter 5, including background on modeling workflow, and most of Exercise 5.1, showing how to create a bridge, support lines, deck, and super elevation. So specific topics that we're going to cover in this video, we're going to look a little bit at the background on the modeling workflow, as this is the first video getting into the bulk of bridge modeling in Chapter 5. Then we are going to get into the software and actually create our bridge, add support lines, and then to be able to create a bridge deck from that. We will also look at how we can incorporate any super elevation that might exist on a bridge. Let's get going. So before we get into our exercise 5.1, our first exercise in Chapter 5, I did want to take a minute to show you the model that we'll be creating here of this structure in the following series of videos. So you can see it's a fairly typical 3-span structure on end bent, pile end bents here, pre-stressed girder structure. So this is, again, the structure that we'll be creating in these series of videos. This is the model that we'll be using through this training manual video for the rest of the sections and the rest of the exercises. I also wanted to bring up a little bit of the background of model-centric workflow. So the model-centric approach in this manual is a little bit different. It's a little bit of a shift away from what we all are familiar with our traditional CAD and developing our details for our plan sets. So instead of creating these separate views in 2D spaces and stitching them together into a plan set, we're creating this 3D model, which will be the central repository of data that will be used and linked to other activities, including plans generation, 2D plans generation. So it's very important as we go through this that the steps to create the model they build upon each other as that data grows and in order to streamline the process. So the model progression, where we create these, how we create these, and in what order is a critical aspect of how we create these models. This software, OpenBridge Modeler, is really built on this model progression and stepwise approach. So as we go through these videos, it outlines not only the tools that we're going to use, but also the order in which to complete these steps to create a successful model. So it's very important, not only just what we're doing, but also the order. And with that, we will go into our exercise. And for our first exercise, we're going to be looking specifically at the deck element as shown here. So we're going to create this deck as our first exercise and also add the super elevation you see here. Now you see I have our dataset file, exercise 5.1 begin, DGN opened up inside OpenBridge Modeler. And now we're going to get into actually creating our bridge and our bridge deck in this exercise. So before we get going, I did want to point out a few things. First, that there is a bridge wizard. This is basically a way to create a model quickly that was added in more recent versions of the software. This is an option for the users for certain types of bridges, but I would be careful of some of the limitations there and loss of control in some of what we create. So the manual and these videos are going to follow the more traditional OpenBridge Modeler approach to this. So there's more information in the volume 1 of the training manual if you'd like more information on the bridge wizard. So you can see we already have our reference information included from exercise 4.1, and now we're going to get into actually creating our bridge. So the first step we do is we're going to add a bridge under the Home tab, Bridge Setup. Go ahead and click Add Bridge. And you can see our dialog box came up. And for us, this is coming pre-populated here, but this is just a description. You can change that to whatever you would like. And this information is also in exercise 5.1 in the manual to make sure we have the right description. We also have the unit category, so we're going to call this bridge to left. Again, just in order, following our manual here. And for bridge type, I did want to point this out. This is, for now, we're looking at a pre-stressed girder bridge, as we mentioned in the previous, looking at the full bridge model. Open Bridge Modeler can also model beam slab steel girders type bridge, also reinforced concrete slab, which we will use for the approach slabs. We'll get into that in several videos from now. Also not included in this training manual in these series of videos, but there also is ability to create cast in place concrete boxes and segmental structures. One more thing, make sure that our feature definition is on bridge decorations. This is a way to control some of the settings on how we use that, and it's important for future drawing generation settings. So we'll make sure we do that. There's more information in the manual on that as well. And for now, we're just going to keep this as the name prefix. We can call it bridge, but we can make that change to whatever we need to in our particular bridge model. So now you can see that I've created the bridge. I've got my dialog box coming out, and now we have the prompts for select bridge alignment. So this is a key area. This will pop up here. And for our case, we want to look at creating, there's several different bridge alignments in this particular structure with dual structures. For this workflow, we are going to select the center line of the construction bridge alignment. So as I left clicked on that structure, you can see my prompts now change and it says set bridge data. It's looking for the name prefix. We already clicked that. So I'm going to, again, left click. And now it doesn't look like anything happened immediately, but we're going to go ahead and open our Project Explorer box. And here you can see we have some additional information. This may be familiar from other Bentley products here. Some that are specific and customized to OpenBridge Modeler. You can see there are two categories down here. And for OpenBridge Model, I'm going to go ahead and select that. And with that information, you can see that we get a drop-down menu here, and we have the information that we just added is now included in our Explorer. So here is our bridge, so we can see that now this is created. As far as the Bridge Explorer, you can keep this docked as I like to, or you can close this and open it up, and as a pull-out box as well. So now that the container for our bridge is created, now our next step is to look at adding our support lines. And this is following along exercise 5.1 step 2. So in this case, we're going to go again, stay in the home tab, go to the next category here, which is the support lines. And we're going to go ahead and place, if you hit the little caret there, we're going to go ahead and place multi-line support lines. So there's several different ways you can add support lines in OBM. This, again, this workflow, we're going to use the multi option. There's more information in the manual on the other options. So in our case, again, we do get another dialog prompt here, so we can continue to use that. So the skew angle, in this case, we don't have any angles, so we're going to leave that at 0. The length in this case is just the length of the support line that's going to be created. It's not necessarily the length of the bridge or anything there. For 200 feet, this just covers basically the full width of our bridge and allows some additional. So again, that can be modified later. For this case, we're going to go ahead and enter in a start span, or a start station and an end station. So we're looking at that. So in this case, we have, I'm going to read again, this is in our manual, but we're going to start station is 342.03.53, and our end station is 343.53.53. 0.53. Again, you may not see all these values pre-populated when you open these exercises. And again, you can refer to the manual, the training manual, to find that exact information. We have a 3-span structure, so we're going to create 4 support lines for each of our substructure units. The direction mode, we typically want to keep that at skew, so we're good there. And we also have a feature definition specifically for support lines points. So we're going to keep that as is. So now we are in the looking at our prompts. You can see that this also prompts for our start station in our outside of our dialog box. So in order to go ahead and select that, we're just going to do a left mouse click for a data point. Now it's asking us to enter our skew direction mode. We're going to, as I mentioned, we're going to use skew, so we're going to enter a data point again, which is a left mouse click. And then you can see our support lines are now added in. We have, again, we already entered in our end station, so I'm just going to left mouse click again. And we get our dialog box here. Here we can make sure that we have all of the support lines are created correctly. In this case, if you have different skew angles for different substructure units, you can go ahead and change these here to customize this, as well as change any of the stations or the span lengths. For our case, this is what we want to see. So we're going to go ahead and click OK, and it will create our support lines. So now you can see we have our support lines. If we zoom in, we can see that the information for the support line number, as well as the stations for each of those support lines, are included. I realized that I forgot to set what my feature definition was set on for my support lines. So we're going to go ahead and check that now. So I'm going to select one of my support lines. Go to my properties, and I can see here that the feature definition is set to support line point. And actually we want these set to support line. So I'm going to go ahead and make this change for this line. And in this particular case, I'm going to have to do the exact same thing for each line. Typically for elements, we can do this kind of wholesale, but in this particular situation, we're going to come through and change these all manually. Looks like this one didn't take. Let's try that again. And now they are all set with the correct feature definition and levels. Now we are going to move on to step 3 of exercise 5.1, and that is creating our deck. So to access our Create Deck tool, we're going to go stay in our Home tab and move over to our Superstructure group and select our Place Deck tool here. You see, as we do that, we get our dialog box. And we're going to go through each of these inputs and talk a little bit more about them. So first is the template name. And right now we have slab with constraints. I'm going to hit the ellipsis on this side and bring us into the available deck templates. And we are going to get into more of the template creation and what's available in the next exercise video. But I do want to show you what's currently available in these deck templates. So here our deck template box, dialog box is up. You can see there are already several FDOT deck slabs that have been created as part of the workspace. We are going to stay with the slab with constraints dialog box, or excuse me, that template, and we're going to go ahead and select that. So now we're keeping with that. As far as the station offset, we could add an offset for the begin or end of the deck. In this case, we set our support lines at the begin and end of our deck exactly, so we're going to keep that at 0. We will have a horizontal offset because, as you remember, we selected the centerline alignment. So we need to shift that over. We're creating the left bridge in this particular case. So we're going to shift that over 32 feet, and notice the negative sign here to move that over to the left of our center line. We don't need to add any vertical offsets. We're going to make sure our add constraint box is unchecked here. We'll show you in a few steps how we will change some of these constraints, but for right now we're going to keep that unchecked. And then there's some additional chord tolerance and the maximum distance between sections that you can change for some of the modeling settings, especially when you are modeling on a bridge on a curve. We're going to keep that at the default values for this example. As far as the deck material, we're going to keep this as the decked concrete class 4. This is all information that's available in your training manual that you can either pause the video and make sure you have these inputs correct, or again, follow along in the training manual. We're not going to worry about the build order right now. We are going to check our feature definitions and make sure that we are on the correct one. As I select the drop-down menu here, you can see there are two options under deck, as approach slab or concrete deck. And again, we want to make sure our concrete deck is selected for this particular case. We could also add a prefix. This is particularly useful if you have multiple decks on a bridge or splitting up into separate sections. In this case, we're just going to use deck as a general prefix. So now you can see the prompt show up as I move the mouse onto the viewing window. It is looking for the select. It is asking to select the first deck boundary, so our first support line. So we're going to go ahead and select our front here with a left mouse click. You can see it updates here on our screen now. It's looking for the select the second deck boundary. Also remember that this is available on the bottom left corner of your screen too, these commands that are coming up for this tool. So we're going to go ahead and select our end support line 4. As I mentioned, we're not going to add any constraints at this particular time to our deck, so we're going to left click with no selected. And now, as you see on our 3D and our 2D view, our deck was now created. Now, beginning with step 4, we are going to add our super elevation to our deck element. So in order to do that, I need to turn on one of my references that I got from the roadway engineer. So in this particular case, I'm going to go to the Home tab, and under Primary Group, hit this tool, which is the Attach tool. And this brings up the references that I currently have attached. This should be familiar to those that are familiar with MicroStation. The same reference tools are available here. In this particular case, I'm going to select my super elevation left model, and I'm going to go ahead and make sure that this is turned on. You can see that is turned on with a check mark there, and also you can see the shading and outline on our viewing windows. So now that is turned on, I'm going to close out of my references box. And now under the Home tab, Superstructure Group, I'm going to look at adding the Assign Super Elevation tool. So I'm going to select that. And one thing you notice about this, there's no dialog box that comes up. We still do have our prompts here, again, on our viewing window and as well down in our left-hand corner of our screen. So it's asking to select our first super elevation section. In this particular case, we only have one super elevation section. So we're going to select that, just going to hover over the outline until it's highlighted and click that. Now it's asking for the next super elevation section. As I mentioned, we only have one, so it's asking to reset to complete this command. And reset in OBM is a right mouse click. So I'm going to go ahead and right mouse click. And now it's asking to select a candidate. So in this particular case, it's asking for our bridge, our deck. So we can select that either on the 2D or 3D view. I'm going to go over to the 3D view and select our bridge deck. So you see as I select our deck element, our super elevation assignment dialog box pops up on the screen. And there's a lot of information here. You can see that we have 2 lanes identified, a left outer and left inner, which matches our roadway template that was provided as part of the super elevation section. And in this case, we need to do some jockeying of positions of our pivot points and template points in order to line up our bridge template with our roadway template to make sure our super elevation is correct. So the first step I'm going to do is select our template point on our left inner lane. I'm going to move that to 0.5. Now I can select the pivot point, which is really what we needed to change. That needs to be 0.0 with how we have our template set up. And now I can change my template point here back to 0.1. So again, we were just shifting those pull down boxes to make sure we have the pivot point and template point correct in order for our super elevation. And this can take some little bit of trial and error, and there's also more information in the super elevation section in the training manual. So after we got that set up, we're going to go ahead and click OK. We get a warning box that tells us that our lane offset doesn't match with the super elevation point X value. This is okay. We're going to show how we can change that. We haven't modified the width of our bridge deck to match our specific project constraints. So we're going to say thank you for the warning, but we're okay. We're going to say yes to continue. And you can see as I select OK, we can zoom in our deck here, and our deck has now been modified with that super elevation. Now we are ready to move on to step 10 of exercise 5.1, where we're going to add variable constraints of the deck to modify the width and the thickness. So in order to do that, we have a couple options. We can go ahead and select our deck element, and as we hover over that, we can see that our properties box can be selected, similar to what we did to change our support line feature definition. So we can go ahead and select that with the left mouse click, and you can see all of our input values come up on the screen. This is certainly valid, and this can be done with any element in OBM, but it's a little finicky, and if you move off of your dialog box there, the pop-up box, then it does go away and you have to do the same thing again. So what I like to do is go up to our home tab and under the primary group, select our properties. And this we can just have docked, or it can be a freestanding dialog box that's up. But again, I like to docked here on the left side of my window here. So now I can go ahead and select. I have the same options here. In this particular case, we want to go ahead and change the variable constraints. So I'm going to go ahead and click the ellipsis, and brings us into the variable constraint dialog box. This can be a little overwhelming when you first open it up. Again, there's a lot of information in the training manual about what's included here, the different sections and the different variables here that are available. So we're going to go through this here and show you what those mean. But again, there's much more information that's available in the training manual. So in this case, we see that under our variable constraints under variables, we have several that are active that are check marks, and that's our slope, our left and right slope. And really what that is our super elevation that's been applied. Okay, so this is what we did in our previous step to automatically populate these super elevation shifts in lane cross slope and the transitions here. So again, these are automatically input from that tool. We can also come here at any time if we don't have that information in a highway file. We can come in here and add these transitions manually if needed as well in our variable constraints. So now we're going to look at selecting our lane widths. So I'm going to go ahead and select our right width, lane 1, and then I'm going to check that for active, so that updates and adds our right lane width as a variable that we can update. So in order to do this, there are different options here. For our case, we're just going to keep it with our mode for support line and from support line 1. So I'm going to click this green addition box here, and really what that does is just add a section here. Okay. Now the information here is included. You can see the start distance and end distance. So this, if you look, is the exact start and end distance of our deck, which is what we want, our full length here. So now, in this case, we're just going to change our length to match, our width to match our particular project constraints. So in this case, we're going to use 31.6½ inches there. And you can see as I update that start value, you can see that the chart up here shows you where that value is at the start and where that would be at the end. So in this case, our end value is still at 20. We haven't moved it yet. This would be if you have a variable width deck. You can accommodate that with these variable constraints. Again, as for our case, we do not have, we have a constant width deck. So I'm going to go ahead and change that to 31.6½. And you can see as we do that, our value evens out, and you can show that we have a constant width throughout this section. We're going to do very similar activity with our left lane width. I'm going to select that. Again, we just have one section here. We're okay with these properties and inputs as is. So we're just going to go ahead and click our green value, green addition box. And in this case, we're going to look at the left side. We just need to be a little bit careful and make sure we select the correct values here. And notice that this is, again, our left width. And just the way the template is designed, this is actually a negative value. So we're going to, again, use our input our deck width for the left lane width, which is -23.6½. Again, this is included in our training manual screenshots, so we can add that in. And also, if you need to pause the video at any time, you can do that and make sure you have time to enter that information in on your screen. So again, as we do that, we see we have our constant width at the correct width. One last section we need to change is the thickness. So I'm going to go ahead and activate that value and make sure we left click on the actual variable. If we don't click and highlight that, you can see that it will stay with our width value. So we want to make sure we activate it and select it. We're going to do the same thing here and just add, use our green addition sign here to add a value. Our start value is, the value that we want to use is 8.5 per our training manual input, which is, again, input here. And take mine. This is also a negative value, so we're just setting our deck, our minimum deck thickness here at 8.5 inches. You can see is reflected here in the chart above. So now we are good. We have all the variable constraints. Again, you can check out more about what's available in the variable constraints dialog box in the training manual. But for our case, we're just going to select OK. And as you can see, right away, our deck has now shifted and morphed in to follow the variable constraints that we've added for the width. And you can see our super elevation is still there as well. Thank you for joining me today for the CAD Office series for F.Connect. This was the beginning of exercise 5.1 of the MBM Intro to Model-Centric Design Guide. In the next video, we will complete exercise 5.1, which will be adding barriers to our newly created bridge deck.